Okay, welcome to the Knox Makers KM-003 candy cane USB powered blinky light kit. We're going to build this kit today. We're going to talk a little about how to solder, how to put this kit together, and how to debug or troubleshoot it if anything happens to go wrong. So to start, just open up your kit and pour the components on the table you're going to work on. Being careful not to let any drop on the floor. We don't want some errant component getting picked up by your parrot and carried off to some strange place in the house, never to be found again. So in the kit, you'll find printed circuit board, you'll find a strip of resistors, and a handful of probably red and white LEDs. That's everything that's in there. On this board, we've already pre-assembled this little USB micro port. So it's fairly sensitive, a little delicate, so we went ahead and put that on there for you. So that's taken care of. And to start building, we're going to start with the lower profile components, which in this case is the resistors. Build those up first, and then we'll proceed to the LEDs. That usually makes these kits a little bit easier. So let's talk about these resistors. So resistors, they often come in these strips like this. You can just peel them off the strips all in one go or as you need them. Don't worry about bending the leads, we'll fix them later. So resistors can be oriented either direction. They're going to go on the board where it says R1, R2, R3, etc. through R19. So that's where they're going to be placed. They can go any orientation. They could go on the front of the board, the back of the board, left, right, whatever you want. It's going to work fine. Resistors don't really care. There's some bands on the resistor. There could be numbers. They're marked in different ways. But there's some bands on these that indicate the resistance value. These particular LEDs that we're using, these self-blinking LEDs, they don't need a resistor at all. They kind of take care of everything in and of themselves. I include them on the kits because it provides some fault protection. If something's shorted or something isn't quite right, it'll isolate the fault to that LED, hopefully, not take out all of the LEDs. So it would make troubleshooting a little bit easier. Also, the resistors make the board look a little cooler. We get to do a little more soldering for the day. So to place one of these resistors, you'll take the component between your index finger and thumb in one hand and just bend the leads with the other hand about like so. You'll get a feel for this as you do it. And then insert it where one of these resistors goes. And you can see there's R1 with a line on each side, and that's the two holes this resistor will go in. I'm going to press it down flush with the board. I'm going to hold it in place and bend the leads out, kind of like 45 or something on the other side to hold it in place while I solder it. All right, so now I've got one resistor in place. I'm happy with it. I want to solder it. So I'm going to flip the board over and get my trusty solder iron. Now, when we go to solder, a couple things you want to do as a good habit. First thing is regularly tin your tip. Tinning it just means melt some solder onto it. The solder should melt and flow kind of around the entire tip. There shouldn't be any dead zones where it doesn't flow. If there is, what you can try to do is just melt a bunch of solder on that place and it may clean it up. Inside the solder, there's a core of flux. When the solder is melted, this flux is sort of released or it's heated up. A lot of that smoke that you see, it's components of that flux burning off. What the flux does is it cleans off, through chemical action, it cleans off any oxidation or some oxidation that has accumulated on that tip while it's been sitting there hot and exposed to the air. So I'm going to tin this tip a few times. It looks really good. Then I'm going to clean it off, just wipe it off on my sponge. You may have a brass sponge or a cloth sponge, whatever you want to call that, foam sponge that holds some liquid. Either one works fine. They're the same. I've had tips last many, many years using either of them. So use whatever you've got. Now I'm going to heat up both the lead. Zoom in a little more, give you a better view. Both the lead and the PCB ring. Here's what I'm going to do. Get the solder iron tip against both to bring them both up to temperature quite a bit. If the board wants to flip around on you, you can hold it in place. I'm going to put my little pinky on the other end and hold it in place while I work. I'm going to get the tip to touch both the lead and the PCB ring at the same time. I'm going to get those both up to temperature for a couple seconds, then feed a little bit of solder in. I can see that the solder is kind of reflowing or flowing onto both of those, both the lead and the PCB. Remove the iron tip and let it cool for a moment. Then repeat on the other side. So as you get some practice on this, you'd like to get to where you can do these solder joints maybe with 2 or 3 seconds of heat. If it takes 10 seconds, don't worry about it. Resistors are not very fragile. You can heat them up quite a bit and they're going to probably work just fine. We're not trying to build an electron microscope that has to work in a lab. We're just trying to make something to show off to our friends in our house here. So if you're getting solder melting onto the board in the lead, it's going to work just fine. So you're good. So you did that. Now we're going to come in with side cutters and just trim this flush. Doesn't really matter if you're right up against the solder, maybe you're clipping some of the solder, maybe there's a little bit of lead sticking out. It doesn't matter. It's just your preference, whatever you like. Just trim it flush. Now I've got my first component, my resistor, soldered in there, and I'm a happy guy. All right, so I'm going to free up the rest of these resistors from this tape, and I'm just going to insert them all in this PC board at once, flip it over and solder them all at once, or at least in larger groups. It's my preference for how I like to work. You can do it however you like to work. Then again, with each one, push it flush with the finger on one side and bend the leads out on the other side. So I'll talk a little about soldering while we're doing this. I'm using a tin lead solder. There are a lot of different types of solder available out there. And there are a lot of very strong opinions as to which one is best. I've used a lot of different solders over the years. They're all the same. For the purposes of a hobbyist, working here, they're all the same. Again, if you're trying to build the next space shuttle to send to Mercury, then you're going to have a crew of people who do nothing but think about how to solder. But that's not us. You can use leaded or lead-free, tin lead or lead-free, either one. They're both about one and the same as far as I can tell. Lead-free solder, a lot of people feel like they need to use a little more heat with them, which might be the case. I don't find that to be too much the case. A little bit, but not a big difference. When you're starting out, you're likely to find, most people seem to find that lead-free solder or leaded solder, tin lead solder, is a little easier to use when you start. The main thing to worry about with tin lead solder is, like any of these things where you're dealing with various chemicals, is clean your hands. The main way that you're going to get exposure to lead through soldering is by getting it on your fingers and then chewing your fingernails or eating your sandwich. That's where you're going to get a little bit of exposure. You're probably not even going to get really much that way, but if you were doing this a lot, then pay attention to cleaning your hands off really well before you go eat lunch. Try not to chew on your fingernails while you do this, right? Similarly, there's a lot of opinions about brass sponges versus wet sponges. I think the biggest factor in tip life is keeping your tip tinned, keeping your temperatures down on your tip, and taking care of it. I don't notice more years or fewer years of tip life due to what sponge people use. If you tin your tip regularly, you'll probably find it lasts a long time. As you go, you may notice that some resistor isn't setting as flush as you like, so just go back, push it down, bend the leads more aggressively on the back. You can bend the leads however you want. You're not going to hurt anything. They're made for this. It's very difficult to overwork the lead metal and break them or anything like that with these components. It'd be pretty difficult to do. Okay, so I have all of my resistors in place. They're all sitting pretty nice and flush. Got my leads bent over on the back pretty well, so I'm going to just start soldering away on this thing. Again, tin your tip a little bit. Everything looks good. Clean it off and solder. So I'm shooting these videos this morning over at the Knox Makerspace here in Knoxville, Tennessee. It's a beautiful late summer morning. I can hear a few folks over in metalworking banging away. I earlier heard a lot of woodworking going on, but it's relatively quiet in the background right now, which is kind of nice. Try to get these done before the real noise gets started later, which it inevitably does. I can hear someone going to town on some sheet metal with a hacksaw back there. Okay, so I think I've got all my resistors soldered on there how I like. I'm just going to take a look over the solder joints, make sure each one looks like it's got a nice look to it. Touch up any of them I'm not in love with. Looks good. Try to remember every time you put your tip back in the holder to tin it first. A lot of people have a habit of maybe tinning it, then wiping it off before they put it in. You want to tin it, then put it in. Leave it there to protect the iron tip. Okay, everything looks good, so I'm going to go in here with my side cutters and trim each of these. You might notice I often just put the tip of my finger at the end of the lead as I trim it. It stops it from flying across the room. Could easily end up sending that across the room into a goldfish tank. I don't know if that's good for anything or not. Okay, I have got all my resistors soldered and I'm pretty happy with those. So we're going to move on to the LEDs. Okay, LEDs are different. They do have an orientation. There's a long lead and a short lead that denotes the long lead is the anode, the short lead is the cathode. And then on the LED, there's also a flat side. If you kind of run your fingernail around the base, you'll feel there's a flat on the cathode side, the short lead side. On the circuit board, you'll see that there's a little line, a white line on one side. There's a round pad and a square pad. Next to the square pad, you'll see a white line in silkscreen. That indicates the anode side. Sorry, the cathode side, the short lead. I was just building a board where the indicator was for the long lead, so I had to think for a second. The line on there goes with the flat on the LED, and that's the short lead. So you want to insert all the LEDs on this board, short lead towards the line, or short lead into the square hole. Just like the other board, you want to put these in and then bend the leads on the back to hold them in place. And these LEDs are a little bit tight. LEDs are just a little wider than the room I left on the board, so you may find they're a little tight, but that's okay. And the way I'm building them, the way I intended it, you can build it however you want for yours. The way I intended it was a string of 3 red, then a string of 3 white, a string of 3 red, then a string of 3 white. So there's approximately an even number of both of those provided with the kit. But you can mix them, match them, however you want to do it. Okay. As I go through, I'm just verifying I did in fact put the short lead to the line. It's a really easy mistake. If you've never made it, then you probably haven't built a lot of kits, or you're just really good at this. Okay, and again, after each row, I'm just checking I did in fact put the short lead to the correct side. Move to the next one. Okay, I have all the LEDs in place now. You can kind of visually look on the back and kind of see that I've got the short lead in the right orientation for all of these. Yeah, looks good. So now I'm going to just solder through these. You may find that it's easier for you if you kind of clip as you go rather than solder all of them. It can be hard to get your solder iron tip into the spots that you need to get it into. So you just work that however you prefer. I'm going to go ahead and get a few of these leads out of my way so they're not poking me in the bottom of the hand as I work. Again, you may try keeping a finger over the end of the lead as you clip them off so they don't fly up in your face or around the room. You don't want a bunch of these leads going across the room landing upon your porcupine. You'll never find them again. The leads, that is. Okay, I'm going to tin my solder iron tip again. Everything's looking good with that. Going to wipe it off and then continue onward. For better or worse, the end is near. Again, tin your solder iron tip and then put it in the iron. Tip will thank you. As I clip off the last of these leads, going to then look over the board one more time, make sure I'm happy with all the solder joints. Doesn't look like I forgot anything. It all looks good. Okay. So we're going to power this up, see if it works. I'll plug in my USB cord, cross my fingers, and hey, look at that. Everything lights up and works as it should. So, what do you do? Hopefully you're done, and this looks great and you're off showing your friends now. If not, here's how you troubleshoot this. So if nothing is lighting up, that's unfortunate. But there's got to be either, maybe your power cord isn't plugged in or the cable isn't good, possibly. The next thing would be, is this jack, the USB power jack, working properly? This stuff should all be pretty foolproof. If for some reason everything is not lighting up at this point, if you have a voltmeter, you could measure the voltage across these two. I'll turn off these lights so you can try to see it here. Across these two small solder joints here. Those two is a 5 volts and ground off of your USB port. So you can measure voltage across there, you should see 5 volts. And that'll verify that you've got power on your cord, it's coming through the jack, probably getting on the PC board. If you still don't have anything lighting up, take the negative lead of your voltmeter, put on one of these larger connection points and touch both sides of these resistors. You should see one side of the resistor has about 5 volts, the USB voltage, and the other would be something lower. It might be 5 volts or it might be something lower, but one side should have that. That'll verify you've got power on the board and you're okay there. At that point, you should have some or all of these lighting up. If there are some that are not lighting up, then there's probably something with that specific LED that's not right. Hopefully, it's just the solder joint needs to be reflowed. So what you do is find the particular LED that isn't working, flip the board over, and reflow the solder joints, the two solder joints for that LED. You'll see a little trace, probably from that LED to one of the resistors nearby. If it's D17, it'll be R17. It should be the one that's paired with it. But you can also see the traces probably if you look carefully on the top or the bottom. And you can, or just reflow a bunch of the resistors that are nearby. It's going to be one of these ones that's nearby. Reflow the joints on both sides of the resistor, reflow the joints on both sides of the LED, it'll probably work then. If not, then there's a good chance the LED orientation is incorrect. So look at the flat, look with your phone, zoom in or something, try to find the flat on the LED, verify that it's on the proper side. The flat should all be on the same side on these, so it should match the others that are lighting up. If you can see the silk screen on there, it should align with the line on the silk screen. If that's not correct, then you'll have to remove the LED and straighten out the leads and put it back in. You can do that by taking your solder iron and bridging both of the solder joints in that LED, reflow the solder, and then pull out the LED from the other side gently with a pair of pliers or whatever you've got. You may need a friend or some help to do that. And that should help anything with any particular LEDs. At that point, you should have a fully working project that you can go enjoy. You can hang it on your Christmas tree, put it on your desk, whatever you want. It's all yours. So I hope you had a good time, and I hope you check out some of the other kits we've got and spend some more time in the Knox Makers Electronics Zone. Thanks.